Hi everybody, today we will be talking about significant digits, and we're going to get right into it. So there's two main rules to follow when counting significant digits. They're also known as sig digs or sig figs, whatever your teacher said in high school. And the first rule is if there is a decimal point present, you count from the left starting at the first non-zero number. And we're going to look at the first example right now so you can see what I mean by that. So I know that example 1, there's a decimal point right here. So I'm going to start counting from the left, but these numbers are all zeros. So ignore, ignore, and ignore. Now I've hit my first non-zero number, I'm going to start counting significant digits. So that's my first one, my second one, third one, fourth one, fifth one. And once you start counting, you don't stop until you hit the end of the number. It doesn't matter what's there. I could have a million zeros after this one, and I count every single one. And that's just something you got to get used to doing. And then the other rule for significant digits is if you have a decimal point and it's not present, you start counting from the right, starting at the first non-zero number, and you'll follow the same set of steps. So I want to look at example 3 for that one, which I have here, just 100. And starting from the right, you have two zeros at first, and these are zero. This is zero. It's not a non-zero number, so I'm not going to count this one, and I'm not going to count that one either. But this one will be my significant digit. So this has one significant digit. I'll write that this one has 5 too. And now let's go with these other two examples. So I'm looking at this number. I see a decimal point is present, so I'm going to start counting from the left. And I'm starting at a digit that is not zero. So I'm going to start counting from here. So 1, 2, 3, 4, 5, 6. Go all the way till you hit to the end of the number. So this would have 6 significant digits. And if I put 2 zeros here, I just keep on counting. So this one would have 8 significant digits. And then now let's look at the last number, which is a little bit interesting. Because it's the same as number 3, but there's a decimal point present this time. And that means I'll start from the left this time. And here we go, looking at this. This is a non-zero number, so this will be my first significant digit. And then I'll count all the way to the end again. So that has 3 significant digits. Math people like to think they're tricky by putting a decimal point in to see if you're really looking at the numbers. And it can be kind of annoying because it's easy to miss. And now I want to move on to the multiplication and division rules for significant digits. And you do the same for each one. But when multiplying or dividing, count each term's significant digits and use the lower number of sig digs for your final result. And let's go through what that actually means. So with example 1, for the first term, I see that there's a decimal point present, so I'm going to start counting from the left. And I'm going to see that there's 1, 2, this is 3 significant digits, this first term. And this second term has no decimal point present, so I'm going to start from the right. And that's 0, so I'm going to ignore it. And now I've hit my only 1 here. So this is only 1 significant digit. And if you put that in the calculator, you will get 501. But there's a problem here. And the problem is this has 3 significant digits. And this one has 3, but this one only has 1. And you always will go with a lower number in multiplication and division. So this can only have 1 significant digit. I cannot have 3. So this answer would be 500. And you can check that. You can count them on yourself. So if I start counting from the right, because there's no decimal point, we have a 0 here, 0 here, so ignore them. And then this is my only significant digit, so you have 1 significant digit here. And let's look at a little more troubling example here. For example 2, I have 0.001023 times 10.00. First of all, I know I have decimal points present in both of these terms, so I'm going to count from the left again. And this is a 0, 0, 0, and I've hit my first non-zero term, so that'll be my first one. And then I count all the way to the end. So this has 4 significant digits. And this one also has 4 significant digits. Because remember, once you start counting, don't stop until the end of the number. Doesn't matter what they are. Once you start, you don't stop. This also has 4 significant digits. And that actually makes it kind of easy for us. Because when you do that in the calculator, you simply get 0.01023. And this, let's double check, decimal point, count from the left, ignore the zeros, and then you have 4 significant digits. So you're all good. And now let's look at some division ones. First of all, we're going to look at 115 divided by 5.0. And I'm going to count the significant digits first, as always. There's no decimal point present here, so I'm going to start from the right. But there's no zeros, so I'm going to start counting right away. So 1, 2, 3. This has 3 significant digits. And then 5.0 has a decimal, so I'm going to start from the left this time. Count 1, 2. And this has 2 significant digits. So if you just type this in your calculator right out the gate, you get 23. And this only has 2 significant digits, which again you can count from the right and you count only 2. But let's say I have another 0 here, so then I would have 3 significant digits here instead of 2. But my answer is only 23, so what should I do? The simple answer is you put your own decimal point and you add a 0, because now I'm counting from the left and I'll have 1, 2, 3 significant digits. They have to match up, so it is essential you have that 0 there. And then in this last example, I'm going to look at 21 divided by 7. And this has 2 significant digits, counting from the right. And this one, also counting from that, only has 1. So this would be 3. And then you would have 1 significant digit with 3, and that matches up. It's with the least term. So I don't need to put 3.0, because this one is 2, this one has 1. So you always go with the lower term. That's how many significant digits you'll need in your final answer. Now I want to look at the addition and subtraction rules for significant digits, because they always put the definition and it's confusing to read and try and understand it. It's easier to kind of see how it works. But the more formal definition is that when you add or subtract, you can only go to the least significant digit, which for most of you probably isn't a term you haven't heard before, and you really won't ever hear it again unless it's about significant digits. So I want to go through some examples. First we'll do 2 addition, and then we'll do 2 subtraction, and you'll see that they all work the same way. So I want to do 110.12 plus 10.1. So normally, if I did this normally, I would say, oh, okay, I get 120.22. But there's a problem here. This term is our least significant digit, which means that it is the smallest decimal. So this one's here, but I don't have a term here. So I can't count this one in our final answer. Our final answer would have to be 120.2. And with this number, you'll round. So if this was 120.28, you would get 120.3, because this is the least significant term. You can't go anything further. And again, it's best to do these by example, because saying least significant digit just doesn't really click when you're first coming out and doing math. So let's look at this really, really long one. Nasty looking problem, first of all. A lot of zeros, a lot of ones. And if I did it normally, I would just get 55.223001. But again, there's a problem here. This one is my smallest decimal place digit. And that means that I can't have these terms at all in my final answer. So my final answer would end up being 55.223. And again, because this is a 1, I'm going to round down, because it's closer to 0.223 than to 0.224. And you'll see that it works the same way in subtraction. So here I have 10 point, and I have minus 5.9. And if you do this out, you get an annoying number. It should be 4.1. But remember, see how these terms match up and these ones don't. If terms don't match up at the end, there's a problem. You cannot have them. So I can't have this 4.1 here. So my answer would have to be 4. And that would be it. And then, now looking at example 4, a little bit more decimal points. And again, when you line all these terms up, the front doesn't matter, just focus on the back half. So these match up, this one doesn't match up. So I can't have this term. So I'll have to round it again. So, and if you do this, you get 75.0123 minus 10.011. Normally, if you just type it in, you get 65.0013. And you'd be like, hey, that looks pretty close, you know? Because this term doesn't match up, I have to get rid of it. So I'll round it based on this number. So your answer in significant digits will be 65.001. And let's say that you had 65.0018 instead for that problem. Well, I would know, since the last terms didn't match up, that I'd have to get rid of this. But this time I have to round up, so I would just go 65.002. And there is one more thing I'd like to talk about, more of a little add-on. And they're called exact numbers. And these are kind of the numbers you don't think about too much, but they're often either constants in problems or other things like that. But an exact number are digits that we know the exact value of. And they have an unlimited amount of significant digits. And these are kind of like numbers that you just assume in daily life. Because an example would be, like, you know that there's 60 seconds in a minute. And there can't be more or less than that. There can't be 59. There can't be 61. Or anything in between. It has to be 60. It's an exact number. And therefore, it would have unlimited significant digits. Because if you only wrote 60, it only has one significant digit. And if you use that in any math, you only ever have one, and that would cause you problems. But we know it's exact. It's not going to change from 60. It's not like you took a ruler to it, and there's some, oh, it's kind of close here when you're looking at a ruler. There's exactly 60 seconds in a minute. And another good way, or a good example to talk about would be, if you count everyone in a room, say there's 25 people in the room, you count all of them. So there's 25, right? There can't be 25 and a half. There can't be 26. There can't be 24. So there's 25 people in the room. So that would be an exact number, and that would have unlimited significant digits. And that's all I have for significant digits. If you have any questions, please leave them in the comments below, and I'll try and get back to you guys as soon as possible. Good luck with your math, and I hope you have a good day.